for today's presentation is Simware RTI, where HLA meets DDS, and we will have a very practical session with all of you. We know that all of you have downloaded our software. We apologize for the inconveniences or for the issues that you had with our licenses and with our incomplete file, but we know that we solved and all of you have downloaded it again. So today José Ramón Martínez, which is our pre-sales lead, will present very briefly which is what is Simware RTI, its principles, main pillars regarding the technology we are using, that, as you know, is DDS. That is the key difference with other HLA RTIs. And our agenda will be more or less how to install the product, what is the structure of the directories and documentation that you have in the installation package. We will talk also about how to set up the environment variables, how to set up the license file, and we will introduce how to configure, how to set up quality of services. We will show how to run the server. We will connect a test client. We will do all the examples in Linux in this occasion, but it depends on the time that we will show you also some examples in Windows. Finally, we will do a complete compiling with the test client, all the environment, and we will show all the things that you should know to have a successful test, a successful evaluation of our software. So, José Ramón Martínez will start in a few seconds. Just before he starts, I would like to remind that you have a tool with a chat, and you can send us all the questions that could arise along José Ramón's presentation. And so I would like to thank you all for coming, and we will have the opportunity, we'll have the chance, it's sure, to discuss privately with you after this webinar all your questions about the product. Thank you very much. José Ramón?
Well, thank you. Welcome, everybody. Well, as Jose Carlos has said, use the questions we have in the webinar any moment. I mean, well, this is going to be very technical, so if you get lost, if you don't understand a thing, or you need more deep explanation of something, please use the questions and I will answer them in the moment or at the end of the presentation. So, first of all, I'm going to make a brief introduction of HLA RTI, our product, Simware RTI. So, what is the main idea of Simware RTI? The main idea of Simware RTI is the use of DDS as the RTI of HLA. Well, DDS was born in 2003 and has become a wide use standard for real-time communication. From the beginning, DDS is a standard for communication. So, for communication and also in real time. So the idea is everything in the standard is oriented to make the communication as fast as possible with all the guarantees you need to guarantee the communication itself. So our idea with this product is using it as the HLA RTI. In the HLA standard, you can make your RTI, your communication layer, the way you want. So we are using DDS. Why DDS? Well, first of all, with DDS we can control the communication. The idea with DDS is that you can guarantee communication all the time. On the other hand, usually with the standard DDS, with the standard HLA, sorry, the idea is trying to avoid the communication if you don't need it. But the idea with DDS is, okay, you are going to communicate all the time, in real time, so the standard has a lot of things to guarantee this communication. Well, with DDS, we can have scalability, we can have fault tolerance. For example, it is possible to have more than one RTI central server with DDS at the same time. Why? Because we can play with quality of services, we can play with strength or with ownership. So you can have at the same time running more than one server, and only one server is going to be leading. But if this server falls, then the other servers will take command of the simulation. So you can have fault tolerance this way. You can also have fault tolerance in more ways. But the idea is, one of the typical problems with HLA is that sooner or later something falls. So with DDS you can solve this fault tolerance thing. Well, another key thing is that with DDS you can use less than perfect communications. I mean, you can use different bandwidths of communication at the same time. You can mix together wireless with Wi-Fi, etc. So the communication can be any, can be a satellite, can be any. It is not necessary to have the big communication bandwidth all the time. Finally, well, by using DDS we can connect with some military platform that use DDS as the real-time communication backbone inside. So this is our product. One side HLA, the other side DDS. Right now it's only 15.16 API. Soon this will be HLA evolved in the other side. Well, both of them, of course. We are going to make a 15.16 and evolve at the same time. In the other side is DDS. We still don't have all these services. This is very important. Right now we are working on time management, for example. So now, some hands-on. We are going to make it work, for real. Well, this is the agenda, more or less. I'm not going to follow this agenda step by step because it could be very difficult. First, we will start with installation, then we will see the directories, the meaning of directories. Then we will talk about license, about environmental variables, about the communication layer, which is DDS, how to tune it, more or less. Then we will run it in the server, and we will see the at this client we have a federate. Indeed, we have here in installation what is, and this federate is an example of how to make this work. Well, we have both Windows and Linux. I will start by doing things in Windows, but I will switch to Linux to show the difference. So let's start with the installation. We have here the directory. Well, in Windows we have 4 elements which we can install. The main element is the jar file. The jar file is the installer indeed, the installer itself. Everything is in this jar file. Around this jar file we have another things here. We have a Java version. Just in case you don't have Java, you can install Java from here. We have Visual Studio Runtime, which is important if you don't have this already installed in your machine, because the server in Windows uses it. So these are the libraries in runtime for running the server. And finally, we have CMake 2.8. Well, CMake, I don't know if you know it, is a tool for cross-compiling, for making a compilation in any operating system. We use CMake to compile both the same way in Windows and in Linux. And at the end, what CMake is going to do is going to find the libraries you need and to make a solution or a project for you in the compiler that is in the machine. I mean, if your machine has Eclipse, then it will build an Eclipse project for you. If your machine has GCC, then it will make a GCC project for you. So it's a all-purpose, general-purpose tool. We are using the version 2.86. So in Windows, what is mandatory to install is only the jar file. If you want to take advantage of all the examples we have in the installation, then you have to install also the CMake tool. So we can now install it. We run it. Well, this works the same way in Windows XP, Windows Vista, Windows 7. The only difference is that in Windows 7, if you choose a directory that doesn't exist for the installation, you have first to make it by hand, because, well, you are not allowed to do that. But in Windows XP, you don't need to do that, for example. Well, we have here the language selection. We can choose between English and Spanish. We'll switch to English. Welcome. A warning we have here, very important. License agreement. You can accept it or not. And now we have the path here for the installation. As I mentioned before, this is Windows 7. If you write here a directory that doesn't exist, then you will have an error. Only in Windows 7. In Windows XP, this won't be. In Windows 7, you have to create this directory. It's a security thing in Windows 7. So we choose a directory, and it says, okay, this exists, or okay. You can use the default directory if you want, of course. Yes. And now we have the things we can install here. Well, first of all, we have the main Simware RTI thing. We have the boost libraries, and these libraries are needed by the Simware RTI for working. These are the libraries for making the threading, etc., all the auxiliary things. We have the Open Splice thing, that is the communication layer. You need to install it. And we have certs also. And certs are files for reading and writing XML files, which are important because we need to read a federation file. Also, if you want to develop something or use the example we have here, you have to check this. And this example runs with Qt 4.6.3. So if you want to use this example and compile it, you have to install also Qt. If you already have Qt, don't install it. Also, finally, the documentation. So it's a matter of clicking next and installing it. 5 minutes or like that. Well, in Windows, what else is needed? CMake. Again, CMake only if you need to take advantage of creating and compiling the federated example we have here. You can install the CMake standard way, and that's all. Well, in Linux is more or less the same. What we have here is the install file. This install file at the end is going to call the jar file, and in the jar file is everything. The difference with Windows is that here you don't need the C++ libraries, of course, and the CMake is inside the jar file in Linux. But it's just the same. Another important thing, in Linux you have to be administrator to install it. So you have to use an administrator user or use a sudo or make a sudo command. You write sudo and you run the install. By the way, in Linux we can run it in Ubuntu 10 and Ubuntu 12 also. Well, you need the password for the administration in this case. And now the installer is just the same. You have it here, the welcome theme, warning. At the end, what we are doing is using Qt for everything and using the same libraries both for Windows and Linux, and using CMake both the same for Windows and Linux. So at the end, it's the same installation and almost the same structure in Windows and Linux. Well, in Linux, by default is the OPT directory. You can use another directory, but if you use a directory that doesn't exist, you need first to create it with an administrator, with an administration user. Well, here are the options. At the end, the options are more or less the same. Only two differences here. First, CMake is in the installer, CMake 2.8. And second thing is we only have one sources. In Windows we need two kind of sources libraries, and here we have only one kind of sources library. So in Linux you only need to install this thing. There is an alternative way of installing this jar file, both in Windows and Linux, is by using directly the Java command line. The idea is writing sudo java -jar and the name of the jar. In Windows you don't need it because you can click on it and run it, and in Linux you can use the install thing. But if you don't have the install thing, or you can run it straightforward in Windows, you can do that with java -jar and the name of the jar file. So now in Windows we can see the directory structure that the installation left. Well, first of all, we have here two sources directories. These directories are the libraries and the included files for running the server and also for creating and running the client, the example client we have here. Sources is used for reading and writing XML files. Well, we have the boost here, and in the boost we have the included files for the example, of course, and we have the libraries for the runtime. Boost is used both in Windows and Linux for all the auxiliary things, for creating threads, for sleep, for strings, for all the auxiliary libraries in C++. We also have the uninstaller thing, that is a jar file. Here we have also the Qt, the full Qt, is the full installation. You don't have to worry about the paths or whatever. I will show you later that we can deal with the paths in a common way, so you don't have to care where are these folders and where is the Qt, etc. We have also the communication layer here, that is this folder called printed. And here we have the full installation of the version 541. The most important directory here is this bin directory. And in this bin directory, there are all the tools and services of OpenSplice in this case. Here you have tools you can use and some other tools you need license to use. For running OpenSplice, you don't need any license. And for running some of the most useful tools, you don't need any license. For example, you have here the mmstat tool that is for dealing with the local memory database of DDS. Well, what is the idea here? The idea here is each node that runs DDS, each node that runs the communication layer, has its own shared memory that is like a database in memory. With this command, with mmstat, using it with a command line, of course, you can check the command line. You can the memory of this database all the time. Here, for example, another very useful tool is the ospl-conf, and this is a bat for editing the configuration of the communication, the quality of service of the communication. There is a file we will see later where it's writing all the communication quality of services. Here with this program you can edit it. Well, this is a full installation. You have also documentation if you want to read it. You have examples also. And finally, the most important directory is the NADS directory. Here we have three very important files. The first one is the environmental file. Here in this bat file, we have all the environmental variables to run the HLA server, and also to run the examples, and also to compile and run any federate of example you can build. I mean, by running this bat, you have all the dependencies to use boost, to use sources, and to use the communication layer. Everything is here. So each time you need to run the server or the client, you first has to run this bat. In Linux there is an equivalent I will show you. Very important, the nxleak environmental variable. This variable is where is the license file located. By default, the license file is in opt nuts directory, but you can change it. You can change it by changing this thing here. Well, we have the license here. It's in the default directory. If you have a license, you have to put it here in the opt nads directory. The same in Linux. We can open it. Okay, let's see. I think it's okay. So, here. Okay, let's open it. And here we can see all the licenses you have installed in your machine. Very, very important. Well, first thing, the version. The version number has to be the same you have installed. I mean, if you have the version 1.1.1, this is not going to run with this license. This license is only for version 1.2, which is the version that is in the website. and very important, the expiration date of the license. Here you have the date where the license is going to expire. Finally, we have this file, and this file is the communication quality of service file. It's very, very interesting. We can open it. We can open it, as I have said before, with this ospl.conf file, but at the end it's an XML file, so you can open it right like that. Here you have a lot of things. You have a lot of documentation also, but things which are very important. Well, first of all, very, very important is the domain. The domain in DDS is like the federation in HLA. If you want to share information using DDS between more than one machine in the same network, they have to be in the same domain and use the same ports numbers. So you can put any number, any name indeed here, and this is the name of the domain. Also very important, the size of the local database you are using. You can change it or not, don't worry. And finally, very, very important thing is this global partition address. With DDS, you can choose the way you distribute information through the network. And here you can say that this can be broadcast, or you can use a multicast direction here, or you can use here some IPs directions. I mean, you can say, okay, this is going to be only for these IPs. The information is going to be distributed, broadcasted, or I can use a multicast direction here. Well, finally, for finishing the directory things, we have a CMake directory here, and here what we have is the for CMake for working, the CMake need to know where are the libraries you are going to use. He needs to find these libraries. So the idea is that here we have our own find for CMake. We are saying to CMake, okay, our libraries, the libraries we are going to use for the compilation are located here. Also, we have the Simware directory. And here in this Simware directory is located the server and the example, the federate we have, for example. In the bin directory, we have all these things. We have this server, which is this file called RTI exec. This is the server. And we have also the example with the federate of example we have. That is the KRTI saves X. Well, we have the documentation. We will go later to the documentation. We have the included files. And at the end, these included files are the typical things you need for HLA. The ambassador, etc. They follow the HLA standard because they are the include things for HLA. And the libraries. The same. Here the libraries are the libraries needed for the standard of HLA 1516. So it's the lib RTI 1516 lib. Also we have examples here. In this examples directory you have all the code for running and chaining the example federate we have here. Well, let's change briefly to Linux to see the difference in directories, and then we will see that running for real. Okay, so in Linux we can install it the same way. And at the end, we will have an structure very, very close to the thing we have in Windows. What are the difference here? Well, the difference is the certes is only one certes directory instead of two. We have the CMake in the same structure, but it's the same. And here the bat file is called Simware RTI source. And well, inside is the same. Yes, the same. You have all the environmental variables. And the only difference is that in Linux you have to use the source command line command to call that. Later we will show this command. It's very easy. It's writing source and then the name of this file. But the effect is the same. The idea is that by running this file, you will have all the environmental variables you need for running the server and for running the federate of example we have there, and for compiling the federate we have an example there, and for making your own federate of example. So in Windows again, well, the idea with these tools is that at the end we support Windows and Linux, but in real time usually people prefer Linux. So the way we run the things is very close to the way the things are made in Linux. I mean, we use the command line. In Windows it's not so natural to use the command line, but since we are doing the same structure in both Windows and Linux, you have to use the command line both in Windows and Linux. So in Windows, for running everything, you need first to make a command line. CMD thing, you open a command line, and then the first thing you have to do all the time is going to run this bat file we have mentioned before. Always you have to run this bat file, the first thing, because in this bat file you have all the dependencies, all the libraries you need for running the server and for running the clients. So we just run it. And now we have all the environmental variables to do anything. By the way, very important, the license only work with the Mac. So it does mean that you need to be connected to a network to run anything. I mean, if you are standalone in your computer, if you don't have any network, then the license is not gonna work. If you are using a different kind of networking, I mean, if you have a license for a wire Mac, then if you change to wireless, you will need another different license because the Mac is different. Take care with that. So you have to use the server connected to a network, and with the same Mac you have choose. Of course, you can ask for another license with a different Mac. It doesn't matter. So now we have made the environmental variables. We have now we have to start the communication layer. You will need to start the communication layer in every node you are going to use. And for starting the communication layer, this communication layer is going to use this file we saw before. You have two very basic commands. All the time is OSPL, this is the name of the server, and you have the command -A for stopping an already existing communication. I mean, if you have already started OSPL, the communication layer, you can stop it by writing OSPL -A. And for starting it, you have to write OSPL start. So So now we have a domain running. We can stop it with -A, sorry, shutting down, starting up. The same commands for both Windows and Linux. If you have run the environmental variables, then you will be able to start and stop the DDS communication layer. The same way in Linux and Windows. By the way, you can communicate Linux against Windows with the same communication layer. No problem, no difference. Well, we need it started, so we start it again. We have it. And now we can run the server. The server, as I mentioned before, is in this directory. And here we only have to call the server. The server is called RTI exec 1516. And we need an argument. And the argument is the domain we are going to use. The DDS domain. In this case, the domain is called 55. So now we have started it and we have the server running. Well, the server has three commands. You can press H and you have the three commands. You can write Q for quitting. You can write L for listing all the federates. And you can write delete for deleting one of the federates. And that's all. And now we can connect any 15, 16 client that could be BR Forces, BBS2, Stage, whatever 15, 16 client you have, without any change at all. Here, for example, we have some client of example. We open another command line. Each time we need to run the same source file. So we run the bat file. We have an example here in bin directory, the same. And the name of the example is RTI saves. Well, this is a federate, like any other. It's only an example. It's not the server, but it's an example we have made. This example, we provide you with all the source code in C++ and all the libraries for compiling it. So feel free of changing this example the way you like. You can add here anything. Well, by default, this server has some arguments. The first one is the name of the federation. This is going to be a federate. The second one is the name of the element itself in the federation. And finally, the final argument is the federate file. This federate file is a normal font file. Any font file is the font file of the federation. So we just run it. And now, well, this is made in Qt. We have a Qt interface. Well, we can run another client in Windows. In Linux, this will be just the same. Even the example is the same, because we are using Qt, the interface is the same, everything is the same. So first we run the environmental variables, and we run another client here, the same domain, another name, and the same federation file in this case, because we are going to be in the same federation. What we are doing here is we are reading this federation file, which is a font file, and we are converting it in the server to DDS. So at the end, we are going to use this federate file in DDS. Well, we have this client. For example, we can start publishing, and we can subscribe to anything here. And by the way, in the example you have there is a bug. There is a bug we can solve right now. So if you subscribe in Windows, you will have the application will crash. In Linux we don't have this bug. Later we will show you how to solve this thing. Well, for example, here we can send this file and in a very, very fast way. In Windows we can run it, well, it depends on the network of course, but here we can see 3000 Hz. We can reach even 10,000 Hz without the communication in this case because, well, this is very fast. Yeah, but you can see it's moving so fast you can see it smoothly because it's moving as fast as possible. We can publish any number of elements, and we are publishing these things to DDS, and this client is reading it as a federating HLA. Well, we can see here that we have in the federation two elements that are these elements. These elements could be VR forces or VDS2 or whatever. Well, we are using DDS, so we can add anytime a new federate, and in the runtime we can incorporate just like that. We can say, okay, we add it right now, we run the bat, and now we can add it, and we can say, okay, a new federate is going to be added with the same font file, and from the beginning you can subscribe to anything or you can publish anything because we are using DDS. Well, what else? Well, we are using HLA. So we have here in this example, because this is only an example, we can acquire the ownership, for example, using the ownership transfer service. We can acquire this instance for me. We can acquire any other thing. So the idea is, but using this, we can acquire things because we are using HLA. So with this example, you can test the server. You can test the federation. You can join, abandon. You can do a lot of things. Well, we can close it. And we can see in the federation that now no element is here. Well, in Linux, it's more or less the same. Well, the difference in Linux, the main difference in Linux is that the bat doesn't exist at all. So the name of the file here is .source, and for running this source you have to use the command called source Simware RTI source. I mean, the command is called source for running the source extension, and that's all. This is the only difference. The server is called the same, the clients are called the same, and are located in the same directory. Well, finally, in Windows, well, as I have said before, we have the code of this example. I have a question, sorry. Well, how do I shut down the server? Well, for shutting down, in this version you need that no federates are connected. So if any federate is still connected, the server will say that it can go down. So first you have to kill all the federates, and then you have to write Q. You write Q, and then it shuts down. We are working right now in the new version so that we are going to incorporate a quality of service of DDS. So if the client goes down, in not a proper way, I mean in the meaning, I mean in the HLA way of doing things, if it doesn't disconnect in the HLA right way, then the server will not know that it's out. So we are going to use a DDS quality of service, that is a time management, and if after a time the client is not responding, we are saying to the client, okay, this client is dead. So that way, in the next version, you will be able to quit it if the client goes down in not a proper way. I mean proper way in the sense of HLA, in the sense of all the protocol you have to use for disconnecting. Well, you have the example code here. This is the full code. You have it here. All the code, all the project. And just for using this code, the only thing you have to do, okay, you go to the directory, and everything here is used by making cmake. So you only have to write cmake and dot. And cmake is going to build, to find the dependencies you need and to build a solution in the compiler you have in your machine. If you don't have any compiler in your machine, then CMake won't be able to build a solution for you. I mean, if you're in Windows and you don't have any Visual Studio or whatever, CMake won't work at all. In Windows, we are using Visual Studio 2005 only right now. Why? Because of the Boost libraries. We have the dependencies in Boost right now in 2005. It's not hard to change these libraries for a version for 2010 or whatever. But right now in the product as is only for 2005 in Windows. In Linux, you can use TCC or you can use Qt Creator or Eclipse, for example. Well, here in this machine, I have more than one version of Visual Studio. So I have created this bat file just to say to CMake that it has to use 2005. This is because in my machine I have 2005, 2008, 2010. So I run this, and now this is going to create all the things for you. And right now I have a solution, in this case for 2005, I can use. So I start 2005. Right now. Okay. So I start 2005 in this case. Well, I can write dev-emp from the command line, but in this case, it's not the default Visual Studio, so I'm using the full path here. And now it's a matter of opening the solution that CMake has made for me. So the solution is here. I open it, and now I can change anything in Visual Studio and compile it again. Well, Visual Studio has, okay, it's taking its time. Well, two very important things in Visual Studio. Very, very important. First of all, by default, the solution set that has 4 elements, and you need to say to Visual Studio that the initial project is the key RTA saves, because if not, it's not going to use this as the first project. It's a matter of changing it and saying, okay, this is the initial project. Well, second thing, very important, is that right now we only support release and mean release in Visual Studio. So don't try to compile it in debug, because we don't provide with the push libraries and the search libraries for debug. So do it in release or mean size release. Well, and that's all. For example, as I said before, there is a bug here in Windows. Well, this bug is located in this file in table model CPP. And it's a matter of fixing it. Well, don't worry if you don't, I'm going very fast now, but later I can send you how to fix that, or the thing fixed. And it's a matter of adding a condition in the data method. And now you can compile it, and that's all. In Linux, and I'm ending, well, just the same. The only difference in Linux is that, well, you can make a CMake. The only difference here, CMake dot, and you have the solution. And the only thing you have to do here is use make all. And by writing make all, you make everything with GCC. You can use CMake here with Qt Creator, with Eclipse, whatever. Well, and finally, documentation. Well, as I have said before, we have a documentation here, and in the documentation directory we have all the documents we need for everything. We have the installation manual, we have the user manual, both for Windows and Linux, and very important, we have the release notes. And here in the release notes, which is very, very important, you have all the bugs. And also, and this is very important, at the end, you have the current version limitations. I mean, this HLA is not full standard right now. We don't provide all these services. So here we describe the things we don't provide right now. We don't have time services, we don't have DDM, and we have some issues with safe restore, etc. We are right now working on fixing these things, but it's very important for you to read these release notes. So, well, this is all. If you have any question, you can write it in the questions, or, well, yeah, write it in the questions. Well, any question about this? Well, of course, I can send you the presentation. I'm recording this webinar, so the idea is to share it with you, because I understand that that doing that way is very hard to follow. Well, right now in Windows we are using only, well, they ask me if we use Visual Studio 2005 or Visual Studio 2008. Right now we recommend using 2005. Why? The only reason is because of the boost libraries we have included. We have the boost libraries for 2005, but it's very easy to download the boost libraries for 2008 or 2010 if you wish, and then you can use 2008. But right now, the installation by default is using 2005. I know that in Windows 7 there are some compatibility issues, but at the end there is no problem at all by using 2005 even in Windows 7. Well, as I mentioned before, I'm going to share with you this webinar that has been, we are recording it. So the idea is, okay, everything I have told you is in the documentation, in the installation, especially in the installation document and in the user manual. But again, I'm going to share with you all this because it's very difficult, to follow everything because we only have 1 hour. Well, any other question?